Assalamualaikum and good afternoon, everyone. My name is Fikri bin HIDAYAT, and we're going to present our project for computing about PHP-based electricity rate calculator on Google App Engine. Without further ado, I will pass to Farizah to explain what our website is and how it will be deployed.
Hi, my name is NURFARIZAH binti Saad. Match number 207340. So I'll start with some introduction of this project. So our group has decided to build a electricity calculator. So the calculator has been built using PHP, and we also utilize Google App Engine as our platform as a service. And the reason why we choose to develop this calculator is we want to make the complex calculation of electricity consumption understandable and transparent for everyone. So in addition, the design of the user interface of this calculator that we built is simple as possible, so that any person could use it without difficulty. So as you can see, this is what our website looks like, and user will be need to input three things, which is first is voltage, then current, and also rate. Then after the user click on the calculate button, it will calculate the total rate. So the total rate will be displayed in two tables. So the first one is the total rate for per hour, and the second table is the total rate for 1 day. So I'll pass to the next person to give more detailed overview about this project.
Okay, thank you, Farizah. Next, I will be explaining about the Google App Engine. So for the Google App Engine, I will be explaining the dashboard. The first one is the project info. It displays essential project details like project ID, number, creation time, and it may include additional metadata. The next one is the resources. It offers detailed breakdowns of resource usage, including the CPU memory and storage metrics. And this function enables fine-tuning of resources allocation for optimal performance and cost efficiency. The next one is trace. The trace section provides advanced tracing capabilities, allowing the developers to visualize the entire lifecycle of a request. And this aids in diagnosing performance issues, understanding dependencies, and optimizing application efficiency. The next one is App Engine. It presents counts for various App Engine entities such as instances, versions, and traffic division. The next one is API Overview. It delivers a detailed overview of API usage within the application. It offers insight into response times, error rates, and usage trends. And this data helps optimize API usage for enhancing application performance. The next one is Google Cloud Platform Status. It provides real-time status updates on the operational status of various Google Cloud Platform services beyond the App Engine. And this helps assess potential impacts on the application due to regional service disruptions. The next one is billing, and it offers a comprehensive view of billing information, including costs, breakdowns per service, and it facilitates expense tracking to optimize costs. The next one is monitoring. It allows the developers to set up custom alerts based on specific metrics for issue notification, and it also provides historical data for trend analysis and capacity planning. And the last one is error reporting. This section includes advanced analytics such as grouping errors by type or frequency, and it provides insight into the root causes of recurring issues. So in conclusion, the Google App Engine dashboard serves as a central hub for developers and administrators, offering information to control and manage the application. I'll pass to the next presenter.
Thank you, Akila, for the Google App Engine explanation. Okay, so I will continue our presentation by implementation. So, as Farizah said earlier, our project mainly implement PHP as our main language in our electricity rate calculator. Technically, it is especially we use PHP vanilla or known as PHP plain. And also we use CSS framework for designing and styling the web page. As you can see in the slide here, there are 6 CSS file, which is table per hour, table per day, button calculate, button clear, font label, and also result container. And then these 6 CSS are connected to the index.php to create the web page before we deploy it in the Google App Engine. And then to deploy it in the Google App Engine, we need to add 3 more files, which is composer.json, composer.log, and also app.yaml, which that file are used to configure and set the web page to the PHP environment or platform in the Google App Engine. All right. Next, to initiate the deployment process in the Google App Engine, we need to open the terminal first or command prompt in our Windows. And then we need to initiate the Google Cloud by using gcloud init command in command prompt. And then during the process, they inquire us the email, and then that email that we use to control the app in the Google Cloud Console. For example, in here, I'm using Aliff2404 as my main email, as our main email to do to control this project in our console. And then we need to make several configurations, such as choosing cloud project ID, select the path or project in our local directory, choose the suitable region according to our place. For example, in here, we are using Singapore, if I'm not mistaken. And then we need to wait for the cloud to initiate the deployment and fetch the data from our directory to be put into the Google App Engine or Google Cloud. Okay, next. Here are the 3 main features that we monitor in our Google App Engine. So there are 3, which is service tab, versions, and also instance. For the service tab, it will display the default service classification, which determines how traffic is managed. Then the second one is version tab. Version will show the overview of the different application version in detail, including runtime requirement, traffic allocation, number of instances, services account, and also platform environment. As you can see here in the slide, we are using PHP as our environment or platform. And then the last one is instance, which show the instance ID, start time, external IP, and health check status. Okay, why there is a 2 instance and also auto scale features? So Google App Engine has dynamically adjust the number of instance to handle the incoming traffic efficiently. And then what means by 2 instance and auto scale? 2 instance mean that Google actually implement 2 instance for each of their developers project. So means that each instance that can operate independently and can handle requests concurrently. And auto scaling is means that Google App Engine can adjust the number of instances based on several factors like incoming requests and response time. This type of allocation by Google App Engine, like 2 instance and also auto-scaling features, can help by allocating resources to the different incoming traffic, which provides scalability to both user and provider. Okay, so this is how the web page looks like. If I can show you a little bit, as Farizah mentioned earlier. Okay. So here is how our web page look like. Technically, we need to use them, but by using Google Cloud Engine, we have deployed, we using the platform as a service to deploy our web page without using any XAMPP or WAMP server like that. We just deploy it in the Google App Engine, or another one is AWS. These two is most popular platform as a service cloud provider. So here okay, as you can see, the table or result has been generated by clicking calculate. This is all the function that we just doing in our CSS and also PHP coding. So I think we will continue with the performance evaluation.
Okay, so I and NADHIRAH will explain the performance metrics. For the first performance metrics, next. Okay, so for the first performance metric is latency. We found that our application demonstrate a robust latency time across various percentile. In the percentile that we chose is 50, 95, and 99. Okay, so at the 50, which is median, the response time, the latency time is quite impressive at 28.93 milliseconds. This means that half of our users experience the response times below this mark. It reflects a solid and consistent performance for a significant portion of our user. Okay, next for the 95 percentile. Oh no, it's still the same. Okay. So for the 95 percentile, the latency recorded is the latency mark is 39.34 milliseconds. This indicates that 95% of our users experience response below this value. And then at 99 percentile, the response time, the latency is recorded at 40.26 milliseconds. This indicates that 99% of our users are experience the latency below that. So it is slightly higher than 95 percentile, but it is still still okay latency. Okay. So this indicate quick responses. Okay, so moving to the next performance metrics. Okay, so the performance metric is traffic. Okay, traffic in Google App Engine indicates that the data flow into and out of the application. It contains it encompasses the volume of information that received from users and external system, as well as data transmitted data transmitted in the form of response and outbound data. Okay, so the receive byte rate is 93.48 byte per second. This indicates the rate at which data is actively flowing into our application. The metric evaluated over the time provide insights into users' activity pattern and potential interaction with external service. The send byte rate here is 36.2 byte per second. This record signifies the rate at which data is actively transmitted from our application. This includes the data as sent as responses to user requests and outbound data to external services. Okay, so next, the VM traffic in Google App Engine refer to data flow and flow into and out the virtual machine that hosts and run the application. The data, this performance metric includes both data that received by virtual machine, like user request and external input, and also the data sent by the virtual machine that typically consists of responses to user requests and any outbound data sent to the external VM. Okay, so the receive byte rate here is 2.9 kilobyte per second. This amount shows that the rate that is actively flowing into the virtual machine. This includes the user input and information from external sources. Okay. This metric provides insights into user activity patterns that guiding us to understand the data intake dynamic. Okay, so for the send byte rate, which is 7.02 kilobyte per second. This represents data that is actively transmitted from virtual machine to our application. This includes responses to user requests and outbound data to external virtual machine. To external services. Next. Okay, so for the next performance metric, it represents the percentage of computational resources that is actively being used by the application. So in our application, the recorded CPU utilization percentage is approximately 5.2%. That indicates that that is the amount of available CPU resources that being used by our application. This falls into normal operating range that suggests that our application is efficiently managing the workload without overburdening the CPU. Okay. So I will pass to Nadhirah.
Okay, thank you, Alia. I will continue with instance, where this instance refer to the virtual machine that run your application or the website. So it will handle all the requests and also respond accordingly. So if you look at this graph, from 5:40 until the 6:30 p.m., only 2 instances are active, meaning that only 2 virtual machines that running the application or website to handle the incoming requests. This is very important to monitor, as we can know how many virtual machines and also identify the trend in the application or the website usage. Next. Okay, the next one is about the memory usage, which is referred to the amount of memory used by the website. And at the 6:02 p.m., it's experienced the highest memory usage, reaching 916.35 megabytes, which one of the possible reasons that might happen is spike in the user traffic, or there are certain operation within the website that require complex data processing. And we need, this is very important to know, as a very high memory usage can impact the performance issues. Next one. And the last one, and the last performance metric will be the disk byte, where if you look at this graph, at 5:41 p.m., the disk activity, it's actively writing the data to its storage at the rate 176.6 kilobyte per second. But at the same time, for the read activity, it's only 0. So the website do not retrieve any data from the storage. And this information about this part is very important, because it's for us to manage the storage efficiently and ensure the website function smoothly. That's all for the performance metric. I will pass to the next presenter.
Now is for the conclusion. So for conclusion, the implementation of this PHP-based electricity rate calculator on Google App Engine shows that cloud computing technology is reliable and also effective for building web applications. And also during the entire practice, the application was well performed by consistently handling VM traffic, and it also shows efficient CPU, memory, and disk usage, which allowed the application never to slow down and data can constantly be processed. So this project not only fulfills its main role as an cost-effective calculator, but it also represents the power of cloud computing for environmentally solution to digital tools deployment. So next, okay, so these are the reference that we refer to in order to make finish this project. And I think that's all for our presentation today, and thank you for your attention.